Hello, and welcome to the demonstration for bivariate analysis. Today, we're going to do a formulaic demonstration for Pearson product moment correlation, and we're going to do an SPSS demonstration for Pearson product as well. Just to give a quick definition of bivariate analysis to refresh our memory, bivariate analysis is looking at the relationship between two variables to see how, in fact, if they are associated statistically, and if so, to what magnitude they are associated. Pearson product moment correlation is the statistic that you would use if you had two variables that were either interval or ratio data, so they had to be continuous variables, and you want to see what in fact the relationship is between those two specific variables. Now here I've written out the formula for Pearson product. Pearson product is typically called Pearson product correlation or Pearson product. I wrote out the entire name here just just for the sake of it. Pearson product is signified by the R symbol. So it's going to be R equals on top of the equation is going to be uppercase N, which is the total number of participants in the data set. So N times the sum total of XY minus, and then you would subtract the total of X times the total of Y, or the sum of X times the sum of Y. So what we're going to do is we're going to multiply the sum of X times the sum of Y, and then we're going to multiply the total number of participants times the sum total of XY. So we'll come to those two, calculate both of those, and then subtract them by each other. Let me just extend this a little bit. Okay, so don't pay any attention to that. So on the bottom of the equation, we have in brackets N times the sum total of X squared minus the sum total of X, which is squared. So we would subtract these two numbers from each other. So it would be N times sum total of X. Do that first, and then you would calculate the sum total of X squared, and then subtract the two numbers. And you would do the same thing with Y as well. So there's a number of calculations that we need to make to plug in all of these numbers to run the formula. So let's look at everything that we need. The first one, we're going to look at the sum of X, which is pretty easy. We're going to also need the sum of Y. We're going to need the sum of XY. And actually, let me erase some of this. And oops. And if you haven't done yet, you might want to jot this down, maybe pause the screen, because I will be erasing this formula. Please write it down and put it in your notes. Then we also are going to be needing to calculate the sum of X squared, and the sum of Y squared. And we're also going to need the sum of X squared and the sum of Y squared. These are all the numbers that we need. Oh, and we also need N. That's needed. So we need all of these things. We have to calculate all of these numbers before we can plug it into the formula and calculate the statistic. So I'm going to erase this formula. If you need, please pause this and write it down if you haven't done so yet. All right. Erasing the board. Oops, here we go. Okay, now we can start all over. Okay. So let's pretend for a moment, and this is a good way to put things in context. Let's pretend for a moment that you work for a clinic, and as part of your initial assessment, you always have people complete an anxiety inventory, and you have people complete a happiness inventory. And this is just a way to round out the clinical assessment to see how, in fact, people are feeling, if they're feeling happy and, what their level of anxiety is. And let's say your clinical director came to you or came to a team meeting and said, look, we have all this data and we want to measure what, we want to determine what, in fact, the relationship is between these two variables to see if, in fact, there is a relationship and to what magnitude it is when they come in for counseling during a clinical assessment. And you were assigned to this team because, of course, you have a good grasp of statistics, and also you can run the formula and also the SPSS. So let's just pretend for a moment that X is going to be happiness. Y is anxiety. Here's the table that we're going to need. So we're going to have to collect all the data for happiness, anxiety. We need the XY table or column to calculate that. We're going to need to calculate X squared. We're going to have to calculate Y squared. And we're going to have to calculate, we'll just calculate all that for now. Okay, and I'm going to erase, well, I guess I can keep happiness on there and anxiety on there for a moment. Create a line here. And then for the sake of simplicity, we're only going to look at 5 clients and what their scores were on this inventories. Remember, let's just assume that both of these inventories for happiness and anxiety they run continuous data, which is, it's really interval data. So that because Pearson product can only run if it is in fact continuous data or is a continuous variables. So let's go ahead and put the numbers in. For the first client, they scored 3 on happiness and a 12 on anxiety. Second person scored a 3 in happiness, and second person and a 9 in anxiety. Third person scored a 4 in happiness and a 10 in anxiety. Fourth person scored a 5 in happiness and then also a 7 in anxiety. And then the fifth one scored a 5 in happiness and an 11 in anxiety. All right. So those, I guess you could calculate as the raw data for for this statistic. So what we want to do first and foremost, we can add up all of X and all of Y. So all of the data for happiness, if we added all this up, 3, 6, 10, 15, 20. So come over here to the sum of X. The sum of X is 20. Do the same thing for Y. 12 plus 9 is 21, plus 10 is 31, plus 7 is 38, plus 11 will be 49. All right. Now we have XY. So now we have to multiply each participant's happiness and anxiety score together. So that would be, if you looked at 3 times 12, that would be 36. 9 times 3 is 27. 4 times 10 is 40. 5 times 7 is 35. And 5 times 11 is 55. And if you add up all of these scores, that comes out to 193. So put it over here, 193. Okay, now we square all of X and Y. So we square each individual score. So for the first participant, 3 squared is 9. Second participant, 3 squared is 9. 4 squared is 16. Oops, there. 5 squared is 25. And 6 squared, and 5 squared is also 25 again. So if we add that up, what does that come out to? That comes out to 84. There you go. That's a bad 4, but it nevertheless is a 4. Okay, now we square all of Y. So 12 squared is 144. 9 squared is 81. 10 squared is 100. 7 squared is 49. And 11 squared is 121. Sorry, this table is kind of messy. We add all that up, that will come out to 495. Okay, now what we need to do is we need to find the sum of x, which is squared. So all we do is come up here to 20, and all we have to do is square x, or square the sum of x, which is 20. So if we square 20, that comes out to 400. And also we need to square the sum total of y. So we have to square 49, which is really 49 times 49. And that comes out to 2,401. And we have how many participants? We have 5 participants. So n will be 5. Now, these are all the numbers we need to fit into the equation for the Pearson product normal correlation. So I'm going to, if you need this table, I would pause this now if you haven't written it down, because I'm going to erase it. 5, 4, 3, 2, 1. Okay. So much nicer than using chalk. Okay, and we do know that x and y, x is happiness, y is anxiety. Okay, so just to go back as a refresher, I'm going to write the formula for Pearson product one more time, and then we're going to plug the numbers in at the top. So R is going to equal n times the sum of x, y minus the sum of x times the sum of y over the square root of brackets n times the sum of x squared minus the sum of x, which is squared. All of this will be multiplied by same thing, but in y. N times the sum total of, sum total of y squared minus the sum of y squared, end bracket. Okay, so let's go back up and let's plug the numbers in, and then we can get started. So start with n. N is 5. 5 times the sum of xy, which over here, that would be 193 times 193. And just for sake of simplicity, I'm just going to put those in parentheses, just so it's easier. And that's going to be times, we're going to multiply that, or no, we're going to subtract that by the sum of x and the sum of y. So, and that's multiplied by each other. So sum of x is 20. We're going to multiply that by 49 over square root of brackets 5, and that's going to be multiplied by the sum of x squared, which is, if we look down on our cheat sheet here, 84 times 84. That's going to be, and we multiply those first, so I'm just going to put those in parentheses, and that's going to be subtracted by the sum of x squared. So that sum of x squared, if you look down here, is 400. 400. Multiply that by 5, which is n, which is 5, times the sum of y squared. If you look down there, that's going to be, so where's sum of y squared? 495. Ah, there we go. And that will be subtracted by the sum of y, which is squared. So that's 2401. 2401. All right, so the formula has been completed, or at least filled with the right numbers. So now let's get rid of the example formula below. 5, 4, 3, 2, 1. Okay, let's go back up to draw. There we go. Okay, so let's calculate all of this out here. Okay. So if we take 5 times 195, that's going to come out to 965. We're going to subtract that by 20 times 49, which is 980. We'll put that over 5 times 84. If you multiply that out, that will be 420 minus 400. That's going to be, if we take 5 times 495, that's going to give us 2475. We're going to subtract that by 2401. Don't forget the square root. The square root of all things. Okay, so now if we take it down a bit, go down another level, and we look at 965 minus 980, negative 15. Negative 15, and then we take 420 minus 400, which is going to come out to 20 times, and if we look at that, that's going to be 2475 minus 2401, 74. And if we multiply 20 times 74, let's just take it this way for a second, that's going to come out to 1480. Remember to get the square root, that's over negative 15. So now if we take the square root of 1480, that's going to give us 38.47. So now all we have to do left is divide negative 15 by 38.47. And remember, the negative is very important. So make sure that your calculator does that, because what the number should come out to is negative 0.39. So R equals negative 0.39. That's the number. All of that, and really a bivariate analysis or a Pearson product lemma correlation analysis should come out to anywhere, it can range from -1 all the way to +1. So -1 to 0 to +1. If it falls within that range, then that looks like that could be the correct answer. If you're getting like 1.7 or 12 or anything beyond that range, then you've done something wrong. So that's how you would look at this. So now we have to figure out, we have negative 0.39. Well, what ultimately does that mean? And how do we know it's statistically significant? So, okay, let's assume when you did these calculations that you decided that you were gonna use a probability value of 0.05, because that's the standard that you would use. And let's say that you, let's say you just wanted to keep it open as a two-tailed test, because you're just leaving it open at this point. So since we are not using SPSS as of yet, we have to do it the old-fashioned way. We have to look at the critical values table in the back of a stats book. So let me pause this for a moment and switch screens. So what you're looking at now is a critical values table for a bivariate normal sample correlation coefficient. So this is a typical chart that you would see in the back of a stats book. So the way that you would use this chart is you would determine whether you did a one-tailed, two-tailed analysis, and let's just say it's a two-tailed analysis, and you measured, at a 0.05 probability level. So so you would use this column here under 0.5, that looks at 0.5 two-tailed test. And then what you would do is you would scroll down and figure out how many participants or how many people were in your sample. Well, we used a very small sample for the sake of simplicity because we don't want to drown in a bunch of numbers doing the formula. So we had an N of 5. So we go to that row, and under that probability, probability of two-tailed test at 0.05, and we have this number, which is 0.878. Now, that is the effect size that is needed in order to be significant for this study. It can be 0.878 or it can be negative 0.878, but the number that we got has to be higher than that in order to be statistically significant. And as you can see, the number that we got was a 0.39. So our data is not statistically significant. Now, chances are, if we put more people into the analysis, let's say we put another, let's say we put another 50 people in, then the number would lower to 0.279, which means that chances are, like if we had a 0.39 and that's 0.279, if we had 50 people in the analysis and then it came out to 0.39, then we would have we'd have statistical significance. So really, we probably we probably do have some something going on here. We just don't have enough people in the analysis to prove it. Because when you only have 5 people, it's got to be a really high threshold to achieve significance. But as of right now, we do not. So that's how you would run a Pearson product moment correlation statistic. If you have 2 variables that are continuous in nature, and you want to see if in fact there is any kind of relationship between the 2 variables. So I'm going to switch screens now, and I'm going to run the same numbers using SPSS and to show you, how that goes. So hold on for a moment. Okay, so I've created the variable view for happiness and anxiety. They're both up here. The names are up here. The decimals are set at 0. There's no values to add because this is continuous data, but the measurement should be at a scale measurement data. So what we do next is we can go down to data view. And this is how the data would look. This is the same data that I gave you for the other table, that happiness for participant 1 was measured at a 3, and their anxiety was a 12, and then it goes down with the other 5 participants. So what we do, if we want to measure using bivariate analysis, we go to Analyze, scroll down to Correlate. Oops. Then we move over to bivariate because we're looking at 2 variables that we want to compare, or not compare, but look for relationships. Now, here are the correlation coefficients. We can either use Pearson, Kendall's Taube, I've never used that, or Spearman. Pearson and Spearman are ones that I'm familiar with. But Pearson, of course, you would use with continuous data, such as interval or ratio data. Spearman would be used if you had ordinal data. So let's leave it at Pearson because that's what we're going to use. Two-tailed test, we're just going to use what we looked up in the book. Basically, we move both variables over to the next box, and we hit OK. Okay, and hopefully you can see this screen this time around. So the correlation table is pretty small, but really what we're looking at is it's 2 tables that within one table that tells us the same thing. That if we look at happiness, and for the Pearson correlation, that happiness perfectly correlates to happiness at 1, but it also relates to anxiety in the same number that we found, which was negative 0.39. Yeah, it should be negative 0.39 if I didn't say that before. Sorry about that if I missed that. but it is in fact a negative correlation with happiness is negatively correlated with anxiety, which, that kind of makes sense. If happiness goes up, then theoretically anxiety should go down and vice versa. However, if we look at the significance level of it, it only comes in at 0.516, which means that it's not significant at all, because in order to achieve significance, it should be under 0.05. So this is an insignificant finding. I think if we added more participants to this, it would probably come out to be significant, but we only have 5, which, we're doing this just for the sake of the exercise. So, all right, well, this has been the exercise, the demonstration for the formula and for SPSS for bivariate analysis, namely Pearson product. If you have any questions about this, please let me know. If not, have a great week.